Alright, we didn't get to go over this section in on class packet 15 part 2. This was section 5. It says create a derivative table, and you're given the following function: s of t equals 1/4 t to the 4th minus 4t cubed plus 16t squared minus 8. I apologize in advance here. I don't have my Apple Pen on me, so we're going to have to go with old school. Alright, zoom in, make it easier. So the first thing we need is the derivative, because we're going to make a derivative table. And we end up with 3 terms, t cubed minus 12t squared plus 32t. We need to find the zeros. You can factor out a t, and then you'll be left with minus 12, and so if I'm factoring out, after I factor out the t, it'll be easy to factor the rest, because it's just a quadratic and it factors nicely. So there we go. So that means the zeros in the derivative happen at 0, at 4, and at 8. Alright? What happens to the left of 0? To the left of 0, if I plug in anything less than 0, I'll get a negative here, a negative there, and a negative there. For example, if I plug in negative 1, I'll get negative 1 times a negative 5 times a negative 9. That's a negative number, which means the function s of t is going down. If I plug in 2, I'll get positive times a negative times a negative. That will come out positive because they'll cancel, which means the function's going up. The value of the function's going up. And if you test, these are what you would have gotten. Okay. So you can see there it's a standard derivative table. But here's the big question. Suppose that equation describes the motions of an object moving rectilinearly in space. Rectilinearly is a fancy word for one-dimensionally. Rectilinear motion is motion along a number line. So think of a brand new number line. Okay, think of a brand new number line. Okay, and the motion's going to be along it. So the motion is in this direction, so this would be positive motion, and this would be negative motion. Okay. So first, let's just look at the table. Well, let's look at the interval that you're being asked about. You're being asked about negative 1 to 8. What is the position at t equals negative 1? So let's check that up here. At t equals negative 1, if you plug in that negative 1, you'll get a 1/4 plus 4 plus 16 minus 8. So that's going to be 12 and a 4th. 12.25 should be the starting position. So that's let's say that's here. That's 12.25. Now, we're going to move from there. So that's where the object starts. So at 12.25, that is the position. Notice that's the s value. it's not the x. It's not the x value or the t value. Okay, because the object's starting at 12.25 at t equals 0. What happens now? Sorry, at t equals -1. What happens now? Well, now the particle is going to move, the object's going to move backwards. How do I know? Well, because initially it's moving backwards. It's going to move backwards for the next unit of time. From t equals -1 to t equals 0, it's going to move backward. And let's see where it moves backward to. So it goes from 12.25 what happens, where is it at t equals 0? Well, everything will zero out. So if I plug 0 back into the original function, I get a -8. So it'll move from 12.25 to a -8. So how far is that? How far is that? I think you can pretty much see that it's 20.25. How do we do that? We always do final minus initial. So final minus initial. That is going to be the displacement. So that comes out, so it's -8 minus 12.25 equals a -20.25. Okay, so we go backwards 20.25. Well, what happens now? Well, now the particle is going to move forward. Right here. From 0 to 4, from t equals 0 to t equals 4, it's going to move forward. Now remember, at t equals 0, the position S is -8. We now need to know what the position at t equals 4 is. So let's actually grab that, S of 4. If we plug 4 in, now we're getting to bigger numbers. If we plug 4 in, we're going to get 4 to the 4th times 1/4, so that's 4 cubed, minus 4 times t cubed, that's 4 to the 4th. 16 times 4 squared, that's 4 to the 4th. So those will actually cancel. It's 64. So it looks like 56 to me. 56. So that means we go from a position of -8 to 56. And so if I do final minus initial position, we get a displacement of 64. Finally, we now move forward. Sorry, backward again for another 4 seconds. If you plug in 8, 1/4 times 8 to the 4th, 8 to the 3rd would be 512 times 2 would be 1024, minus 4 times 8 cubed plus 16t squared. Take a moment now to calculate that. I'm not coming up with it off the top of my head. And you'll see it comes out to -8. So you have a -8 final position. S of 4 was 56, and so you end up going backwards to 64. Okay, so you went backwards 20.25, you went forward 64, and then you went backwards 64. If you add them all together, you'll get a total displacement of -20.25. In other words, the displacements really just, they cancel each other out. And what you'll find is if you plug this function into y equals, if you plug the original function into y equals and then do a and then just find the displacement on the whole interval, I'll show you in a second, then you actually get the same number. So put that function into y equals, get y1, and do y1 of 8 minus y1 of -1. And you'll find out you get -20.25. In other words, this is the same as final minus initial without even breaking it up. That's great, it's the same. So that's total displacement. You see that movements cancel each other out. Distance is a much different word. So distance traveled is much different than displacement. Distance traveled treats every leg as positive motion. So really, to find distance traveled, we're going to take all this math here, and we're going to treat each value as positive motion. So that means it's 20.25 here. Each is going to become positive motion. Now, of course, 64 is already positive motion, but the point is that every leg is positive motion. So I'm putting absolute value signs around everything. So this is the total distance traveled, and it comes out to 148.25. At least by my reckoning. So, total distance traveled, first of all, can never be negative because you can't travel negative distance. You can be displaced negatively. That's what we see in number 1. Okay, now the questions of average velocity and average speed. These are just definitions. Average velocity is total displacement over time. The time would be 8 minus -1, so -20.25 divided by 9. And you get a -2.25. That's average velocity. Average speed, you might have already guessed, is total distance traveled. Right? Because this particle was moving a lot, or this object was moving a lot. It moved 148.25. It just kept doubling back on itself. And it did that over a time period of 9. So 148.25 divided by 9 is 16.472. And so that would be average speed. And that is the difference between the two. Thank you.